We'll begin this lesson by talking about what we mean when we say we're going to solve a right triangle. Well, here's what we mean. To solve a right triangle means to find the measures of all the angles and sides of the triangle. Now, obviously, if it's a right triangle, you know the measure of one angle, don't you? One of the angles measures 90 degrees. But if you are given two of the sides, then you should be able to find the other two angles and the other side. Or if you're given one angle, which is one of the acute angles, and one side, knowing that you also have a right angle, you should be able to find the other unknown parts. Now, when we find the measurement of a side, it is a measurement, and measurements are approximate. Consequently, we have to round. So before we actually start solving these triangles, I'd like for us to review what we mean by exact numbers and approximations, and then we'll talk a little more about the rounding. When we round, we say we're rounding to a significant digit. And of course, we've already talked about rounding to significant digits, haven't we, in some of our other lessons. We know that a number that represents the result of counting, or a number that results from theoretical work and is not the result of a measurement, is an exact number. For example, the number of students in your trig class. If it's 35, that's an exact number. They're not 35 and a half or 35.826 students in your class. Or theoretical work would be an example of a number that is in a formula. When we find perimeter, it equals 2 times the length plus 2 times the width. Well, the 2's are exact numbers. But most of the values of trigonometric functions are approximations, and virtually all measurements are approximations. When we find the value of an approximation, we round the value, and we have certain rules to determine the significant digits for rounding. Now, I'd like to give you some of the rules that we use that most trig books include when they teach this section on solving right triangles. The truth is that usually by your information given, you can tell how you need to round. And another thing I'd like for you to keep in mind is that as you do your work, do all your calculations and round only at the end. Don't round when you're in the middle of the problem. But let's look at these rules. Calculations with significant digits. The first rule we have is for adding and subtracting. Round the answer so that the last digit you keep is in the rightmost column in which all the numbers have significant digits. I thought maybe I would just give you an example. Say, if I were adding say 25.6, and we'll pretend like that this is the side of a triangle and it's meters, and if I were adding well, of course I know to add I have to line up the decimals. Now this first number is rounded to 3 significant digits and is the second number. But what my rule is telling me, first of all, go ahead and add. I have a 7, 8, 8, 2, and of course that would be meters. But notice it says round the answer so that the last digit you keep is in the rightmost column in which all the numbers have significant digits. Well, let's see. The rightmost column, well, this would be the rightmost column. Do both of my numbers have significant digits in this column? The answer is no. So let's look at the next column. Do both of my numbers have significant digits in this column? The answer is yes. So I need to round to, in this case, it's the tenths place. Since this is a 7, I know I'll add 1 to the 8. So for this calculation, I would round to 28 and 9/10 meters. Now let's look at the rule for multiplying and dividing. For multiplying or dividing, round the answer to the least number of significant digits found in any of the given numbers. So suppose that I wanted to multiply 6.28 times 25. Well, we'll just do the multiplication as regular. 5 times 8 is 40. 5 times 2 is 10, plus 4 would give me a 14. 5 times 6 is 30, plus 1 would give me 31. 2 times 8 is 16. 2 times 2 is 4, plus 1 would be 5. 2 times 6 is 12. We'll add. And let's place our decimal 1, 2 places, so we'll come over 1, 2 places. And now notice what it says. It says round the answer to the least number of significant digits found in any of the given numbers. Well, how many significant digits does this have? It has 3, doesn't it? How about this? It has 2, doesn't it? So since this one only has 2 significant digits, that tells us we want to round this to 2 significant digits. Well, the 2 significant digits would be hundreds place and tens place. So we look at the 7. Since it is a 7, that tells us to add 1 to the tens place. So our answer here would be 160. Now keep in mind that in most math that you do, you want the exact answer. But for some of the calculations, when we work with right triangles, since we're working with measurements, we will have to round and we'll want the approximation. So these rules are good only if for some reason you are looking for the approximate numbers instead of the exact numbers. Let's look at this last example. For powers and roots, round the answer so that it has the same number of digits as the number whose power or root you are finding. So I thought that we would just maybe take uh, 2.5 and square it. Well, of course, when we take 2.5 and square it, the exact number we get is 6.25. So if they were asking us for the exact answer, that is certainly what we would put there. But if we were supposed to round, if we were looking for the approximate number, then it tells us that round the answer so that it has the same number of digits as the number whose power or root you are finding. So I'm raising 2.5 to the second power. How many digits does it have? Well, it has 2. So I'm supposed to round this to 2 significant digits. So the 6 is significant and the 2 is significant. So I'm going to look at the 5. Since it is a 5, I will add 1 to the tenths place. So rounding, I would have 6.3. Now what I'd like for us to do is to look at how we determine how many significant digits to round an angle to. Significant digits for angles. If we want to round an angle to 2 significant digits, then it should be rounded to the nearest degree. Now, I have some examples of this that I thought we would work through. And the reason I wanted us to work through this is because my students, even when I tell them what they need to round to, they tend to make mistakes. So, if you were calculating on your calculator, you might come up that some angle was equal to this quantity, or you might take the quantity and convert it to degrees, minutes, and seconds, and you might come up that it's equal to this quantity. Well, given either one of these quantities, if the angle needs to be rounded to 2 significant digits, we need to round to the nearest degree. And of course, in either one of these, the 5 represents the nearest degree, the nearest 1 degree. So we would look at this 5, and since it is a 5, that would tell us to add 1. So rounded, this would be 66 degrees to the nearest degree. Now, what if you're looking at the measurement of an angle and it's given to you as 65 degrees, 33 minutes, and 24 seconds? Well, if you want to round to the nearest degree, what you have to do is look right here. Anything that was greater than half of a degree would tell you to round up, and if it was less than half a degree, you would round down. Now, how many minutes are there in a degree? There's 60 minutes in a degree. So how many minutes would be in half of a degree? 30 minutes, that's right. So in this problem, if this quantity is 30 minutes or more, we would add 1 here, but if it was 29 minutes or less, then we would leave this as it is. But since this is greater than 30 minutes, we would round up by adding 1 to the 5, and we would have 66 degrees, and that would also be to the nearest degree. Now, suppose that we are supposed to have 3 significant digits for our angle. We want to round it to 3 significant digits. Well, if the angle is given in minutes and seconds, we want to round to the nearest 10 minutes. If it's given in decimal degrees, we'll round to the nearest tenth of a degree. So let's look at this same example. And of course, since this is in decimals, we want to round to the nearest tenth. That says nearest. That's pretty messy, isn't it? The nearest tenth of a degree. So we know this is our tenths place. So we'll look right here at our hundredths place. Since that is a 2, that tells us to leave the digit in our tenths place alone. So that would be 65.5 degrees if we wanted a rounding of 3 significant digits. Now, if our angle was in minutes and seconds, 65 degrees, 33 minutes, 24 seconds, then we're supposed to round to the nearest 10 minutes for 3 significant digits. So 33 minutes is between 30 minutes and 40 minutes, isn't it? So which is it closer to? And what you can do is, here's your 10 minutes, isn't it? Since this is a 3, that tells you not to add anything here. And since we want the nearest 10 minutes, that would be 30 minutes, wouldn't it? So that would be nearest 10 minutes. Now let's look at this fourth problem. Or I guess really it's just the third one. It's just got a 4 there because what if we want to round the angle to 4 significant digits? Well, if it's in degrees, minutes, and seconds, then we want it rounded to the nearest minute. And if it's in decimal degrees, we want it to round it to the nearest hundredth of a degree. So let's do the decimal degrees first. Of course, the 2 is the hundredths place. So we'll look at, in the thousandths place, we have a 6. And since it is a 6, of course, we'll add 1. That'll give us 65.53 degrees. And that would be rounded to the nearest hundredth of a degree. Now let's look at our degrees, minutes, and seconds. We want to round to the nearest minute. So in order to round to the nearest minute, we'll have to look at our seconds. Now once again, how many seconds are in a minute? There's 60 seconds in a minute. So if we have 30 or more seconds, we will round up to the nearest minute. If we have 29 or less seconds, then we will just literally ignore the seconds. So how about this? It's less than 30, isn't it? So this angle would be 65 degrees, 33 minutes. That's less than half of a minute, so we don't write it. And that would be rounded to the nearest minute. Now let's look at this next example, and this doesn't happen very often, but suppose we wanted to round our angle to 5 significant digits, then that would tell us that we would want to round it to the nearest tenth of a minute or the nearest thousandth of a degree. So let's do decimal degrees first. Maybe we'll do a little fold here so the screen doesn't seem quite so cluttered. Okay? Alright. So if we want to round this to the nearest thousandths, there's my thousandths place. So I look at the digit to the right of the thousandths place. Since that's a 4, that tells me to just leave the 6 as it is. And of course I drop the 4 and the 8, don't I? So that would be to 5 significant digits. Now let's look at this. Now notice it doesn't say to round to anything of the second. I'm supposed to round to the nearest tenth of a minute. So I have to figure out what part of a minute these 24 seconds are. And to do that, remember how to convert seconds to minutes. Since there's 60 seconds in 1 minute, the way we'll figure out what part of a minute 24 seconds represents is to take the 24 and divide by 60. So you'll just take your number of seconds, divide by 60, and that will give you what part of a minute that is. And did you get that it's 4/10? How nice that it was already rounded. So these 24 seconds represent 4/10 of a minute. So this angle would be 65 degrees, 33.4 minutes. Now that we've reviewed a little rounding, we'll solve some right triangles. Basically, when you are asked to solve right triangles, you're given two types of problem. So let's talk about that for a minute. Of course, if you are asked to solve a right triangle, you know that it has one right angle, and so that's a given. In addition to knowing the right angle, sometimes you are given one side, and it doesn't matter which side of the triangle, and one of the other angles, which of course is an acute angle, because we know a right triangle has two acute angles and one right angle. Or you can be asked to solve a right triangle when you are given two sides. These are the only two types of problems that you'll have. Obviously, if it's a right triangle, you know you have the right angle, then you will be given one side and one acute angle, or you may be given two sides. And you would be expected to find the other three unknown parts. Now, sometimes beginning students wonder, well, why couldn't you be given that it's a right triangle, so you know it's a right angle, and the two acute angles? Well, if that was the information you were given, you would have three angles. And there are an infinite number of triangles that would have those three angles. So the reason you're not just given two angles is because it doesn't define just one unique triangle. All right, well, let's look at a problem. Now, notoriously with these problems, you have some problems where the sketch is drawn for you, and you can see, as usual, we're labeling the angles with capital letters, and the right angle is capital C. Now, in this case, the 578 meters represents the length of the hypotenuse. The 35 degrees 40 minutes represents this angle right here, right in there. I couldn't fit the printing in there, which is why I didn't actually put it in there. Remember what I told you about the rounding? Usually by the information given, you can tell how to round. So let's look at this information. This side is given to three significant digits. This angle is also given to three significant digits. It's 35 degrees 40 minutes. It's rounded to the nearest 10 minutes. And remember, the nearest 10 minutes represent three significant digits. Now, when we get ready to find sides, we'll want them rounded to three significant digits. And when we get ready to find angle B, we will want it rounded to the nearest 10 minutes. So, notice that for this problem, we are given one side and one angle. Usually when I'm given one side and one angle, I find the other angle first. I know that if angle C is 90 degrees, that there are 180 degrees in a triangle, and if this angle C takes up 90 degrees, then the sum of these two angles has to also be 90 degrees. Of course, we know that if the sum is 90, that those are complementary. But the point is, to find this angle B, since I know that they are complementary or their sum is 90, I can simply say 90 degrees minus the angle A. Now, when I subtract that, I like to line that up We'll write the 90 degrees as 89 degrees 60 minutes. We know we can do that because 60 minutes equals 1 degree, and 1 degree plus 89 degrees equals 90 degrees. Then we can subtract the 35 degrees 40 minutes. You want to subtract minutes from minutes, and then of course degrees from degrees. 40 from 60 leaves you with 20, and then 5 from 9, and then 3 from 8. So our angle B is 54 degrees 20 minutes. If you wanted to check that, then what you would do is you would add 35 degrees 40 minutes and 54 degrees 20 minutes, and they should add to 90. So we have one thing. The other two things we need to find here is we need to find side B, which will be little letter b across from angle B, and side A, which we'll label as little letter a because it's the side opposite or across from angle A. Now it really doesn't matter which side we find next. What we do is we decide which side we want to find, and we relate it to the information that was given in this triangle. Do you remember which information was given? We were given that the hypotenuse, the side across from the right angle, was 578 meters, and that angle A was 35 degrees 40 minutes. Let's find side A first. Well, let's see how side A, the hypotenuse, and angle A relate. Side A is opposite angle A. So what we do is we figure out what function for angle A, what trig function is composed of opposite and hypotenuse. Well, of course, there are two, but we will use that the sine of angle A equals the side that is opposite it, which would be side A, divided by the hypotenuse, which would be 578. Now, of course, we know the cosecant uses opposite and hypotenuse also, but since we don't have a cosecant button on our calculator, we usually find that it's easier when solving these problems to stick to the sine function, the cosine function, or the tangent function, because those are the buttons on our calculator. So what we do here is, for angle A, we'll write sine of A, we'll write sine of 35 degrees 40 minutes equals side A divided by 578. Now we want to solve for A. We will clear the denominator. So to do that, we will multiply both sides of this equation by 578. Of course, those divide out, and what we have is that A equals 578 times the sine of 35 degrees 40 minutes. So what we want to do is to take 578 and multiply it by the sine of 35 degrees 40 minutes. Now, since your angle is in degree mode, you'll want your calculator in degree mode, and you're going to have to calculate what the sine of 35 degrees 40 minutes is. Now, when I do it, I use a scientific calculator, and I'm going to assume that you know how to calculate the sine of 35 degrees 40 minutes. Just be sure when you put this in your calculator, you have to convert 35 degrees 40 minutes to decimal degrees. And maybe I'll write the steps up here. Now these would be the steps for a scientific calculator. We'll go 578 times And then for a scientific calculator, to get it to convert to decimals, we'll put our parentheses, our 35 plus 40 divided by 60, close parentheses, and that should convert this angle in degrees and minutes to decimal degrees, which that's how our calculator wants it. And then we'll push our sign button, and then at the end, I don't have much space, but hopefully you can see, push your equals button, and you have to push that equals button to get it to do your multiplication. If you don't push your equals, you'll just have the sign of this angle. So calculate that. And we get this number, 337.01366864 is what my calculator says. Now, a couple of things I want you to notice. Notice that I didn't stop and calculate and round. I put the 578 in the calculator and I did the whole problem, multiply, found the sine of the 35 degrees, 40 minutes, and got the final answer, and then I rounded. Wait to round until you get to the end. And what do I need to round to here? I haven't actually rounded yet, have I? Because I was given the hypotenuse in 3 significant digits. Then I want this rounded to 3 significant digits. So side A equals 337 meters. Now I need to find side B. When I get ready to find side B, it is safer to always use the information given instead of using the information that you found, because if your information was wrong, for instance, if I wanted to use side A to find side B, if I miss side A, then I would also miss side B. So let's go back to the original problem. We were given that the hypotenuse was 578 meters long. We were given angle A. So since we're looking for side B is adjacent to angle A, and of course 578 is the hypotenuse. So what trig function of angle A will we want to use? Adjacent hypotenuse, we want to use cosine of angle A equals adjacent, which is our side B we're looking for, over 578. Well, we'll solve for B by multiplying both sides by 578. You know what I should do before I start solving, though? What should I do here? I should write what side A is. I'll do that right here. 578 times, it's not side A, it's angle A. I need to write 578 times the cosine of angle A. Angle A is 35 degrees, 40 minutes equals, and of course those will divide out. So that's what B is. I won't go through those steps again. If you need to review how to find the trig function values for an angle in degrees and minutes, then there is a tape on calculating the trig function values, and you might want to review that tape. So let's calculate. And we get that side B, and here's what I get. And of course I want it rounded the same way that I rounded side A in the hypotenuse. So since this is a 5, that tells me to round up, add 1, so I get a 10, add 1. So what I end up with here for B rounded, my approximate number is 470, and of course that is meters. So when it says to solve this triangle, notice I got these 3 answers. Angle A is 54 degrees 20, angle B is 54 degrees 20 minutes, side A is 337 meters, and side B is 470 meters. And of course I already knew angle C, side C, and angle A. Now, what I tell my students to do is to do a little check when they solve a right triangle. The longest side should always be across from the right angle, and the shortest side should be across from the smaller acute angle. And that doesn't, just because the numbers work out to be smaller or larger doesn't make it right, but sometimes if you've made a calculator error, you can tell. So let's look at that last problem. Check it out. Which side was the longest? 578, and it's across from C. If I had gotten either one of these sides to be greater than 578, I'd know I made a calculator mistake. Let's check one other thing. Where's the smallest side? That's side A, 337. Is it across from the smallest angle? Sure enough, it is. 35 degrees 40 minutes is the smallest angle in the triangle. So like I said, that doesn't mean that it's correct, but sometimes if you've made a silly calculator mistake, you can find it with that real quick check. Okay, let's look at the last type of problem that we have when we solve right triangles. That's when we're given 2 sides. Notice this says solve the right triangle, give angle answers in degrees and minutes. Well, notice what you're given. This time, you are not given the triangle sketched. You're just given little b and little c. Well, little b is assumed to be across from angle B, which is assumed to be an acute angle, and little c, of course, is the hypotenuse. So I always like to sketch. Of course, you don't have to sketch, but I just like to. And I know that C is 67.8, and I can put angle A and angle B wherever I want to. Let's try A up there and B down there. And now since this is little b, it is the side or leg across from angle B. So I know that this leg measures, and maybe I'll write it like this, 45.2 centimeters. So look at what I need to find. I need to find side A, which is opposite angle A, and I need to find angle A and angle B. Well, of course, both of these sides are rounded to 3 significant digits, so that tells me side A should be rounded to 3 significant digits. But since I don't have one of the acute angles given, I can't judge how to round, and that's why when you're given 2 sides, usually the instructions tell you how to round for your angles. Well, when I'm given 2 sides, it's usually easier to find that third side, and of course I know to use Pythagoras, and since I'm looking for a leg, my leg is equal to, of course it's positive because it represents the side of a triangle, the square root of, and I take the hypotenuse squared and I subtract from that the leg squared. And once again, when you calculate this, don't calculate and round and calculate and round. Do this whole thing. Now, on my scientific calculator, what I have to do is put 67.8 in and push my square button, then subtract 45.2, then push my square button, and then I have to push my equals to get it to do the subtraction, and then the last thing I do is to push my square root. All right, I need to round that, don't I? What do I use to help me know what to round? Well, side B and side C are rounded to 3 significant digits, so I need to round what I got here to 3 significant digits. I got 50.53, and of course it keeps on going, but rounding, I get 50.5, and that would be centimeters. So that's the length of side A. Now we can either find angle A or angle B. I'm going to choose to find angle A, and remember that we take the information given in the original problem, which in this case is side B measures 45.2 centimeters and the hypotenuse measures 67.8 centimeters, and we see how these relate to angle A. Well, side B, the 45.2 centimeters, is the leg that is adjacent to angle A. So adjacent and hypotenuse is the cosine function. So to find angle A, we will set up the equation cosine of angle A equals the adjacent 45.2, the length of the adjacent leg, divided by the length of the hypotenuse, which is 67.8. Now, on the right side of this equation, we have a cosine value. Now, the problems we've always worked before didn't have this cosine value like this. It just had one single decimal number over here. But how do we find the decimal that this is equal to? Well, we just divide that out, don't we? So I'm going to write something over here to the side to help you focus. But when you work the problem, I really wish that you would not do this. I'm going to take the 45.2 and divide it by 67.8 and then write a decimal approximation for it. And when I do that in my calculator, the decimal approximation to 4 significant digits is 0.6667. Now, like I say, I don't really want you to do that, but the problems we've worked previously have looked like this. We have been asked to find angle A when we've been given the cosine function. To do that, what is it we have to use? When we're given the cosine function and we're looking for the angle, we'll have to use the inverse function, which on our calculators is usually second function cosine. So if I was going to calculate this, of course, because I want my angle in degrees, my calculator would need to be in degree mode. And I'm going to write down the steps for my scientific calculator. What I would want to do is I would want it to divide this out first, so I would go 45.2 divided by 67.8, and then I want to push my equals to get it to divide. And after you do this, you should have this number in your calculator, and then to find the angle whose cosine is equal to this number, use your second function button and then your cosine button, which of course when you use that second function button before that cosine button on most calculators, that represents the inverse cosine, and we know that because above the button on the calculator we have the inverse cosine symbol. So what did you get for your angle A? Now here's what I got. I got that angle A was equal to 48 point, and then I got all these decimals places, and you don't really need all those, but I just want you to have an idea of what you might be looking at. You may have more decimal places depending on your calculator and how your calculator rounds. Now, if it had asked me to give this angle in decimal degrees, then I would have rounded. Because my sides were given to me at 3 significant digits, then I would want to round this to 3 significant digits, which would be the tens place. But that's not what it asked me to do, is it? It asked me for degrees and minutes. Do you remember how to convert decimal degrees to degrees and minutes? Well, of course, the whole number degrees, the 48, is the same in both. I've got 48 whole degrees, and then of course minutes are parts of a degree, and so what I have to do is I have to figure out what part, how many minutes this decimal degree represents. Do you remember how to do that? Well, what you do is you have to take this decimal part and multiply by 60. And that's because there are 60 minutes in 1 degree. Now, usually what I do is I just leave this number in my calculator. I subtract the whole number of degrees off. I just say subtract 48, and of course what you're left with is just the decimal, and then that's the part that you want to multiply by 60. When I do that, I get 11.38, and it keeps on going, but that represents, pardon me, that represents the number of minutes. In other words, this decimal part is approximately 11.38 minutes. Now, the question is, what do I need to round these minutes to? Do you remember when you have 3 significant digits and you want to round your angle to degrees and minutes? It's the nearest 10 minutes. So I want the nearest 10 minutes, so I don't really even have to pay any attention to this decimal part. Here's my tens place. If I want to round to the tens place, then I'll look at the ones place, and since that is less than 5, I know that I just keep the 1 in the tens place and I write a 0 in the ones place. So 11 minutes to the nearest 10 minutes is 10 minutes, and of course we know that. What's 11 minutes closer to 10 minutes or 20 minutes? Well, it's closer to 10 minutes. So our angle A, rounded to 3 significant digits, written in degrees and minutes, is 48 degrees 10 minutes. Now I need to find angle B. Well, now truthfully, what I'm supposed to do to find angle B is I'm supposed to go back to what was given in the original problem. I don't ever do that. This is where I cheat just a little bit. I will do what I'm supposed to do, and then I'll show you how I cheat. Alright, so I want to find angle B. Maybe I'll just write right up here. I've got side A. let's write angle A equals 48 degrees, 10 minutes, and then we'll find angle B. Okay. When I try to find angle B and I'm looking at what was given, well, I was given side B, which is opposite angle B. It's the leg that's opposite angle B, and I was given the hypotenuse. So the function of angle B that I can use to set up an equation is the sine of angle B equals opposite, which is 45.2, divided by hypotenuse, which is 67.8. And I'll find angle B using a scientific calculator by inputting the 45.2 divided by 67.8, push equals to divide, and then to find the angle that has a sign that is equal to this number. And of course what you should get here is that if you want to do a little check on your calculator, that 0.6667, now I've rounded that, but that should be enough that you can check to be sure you're on the right track. And then hit your second function, and then this time we want the inverse sine, don't we? And that's what you'll get on most calculators if you use that second function button. And did you get that angle B equals 41 point, and then you get this long decimal depending on what calculator you're using and how you have the rounding set. And once again, we have to convert the decimal part, the part that is just part of a degree, so many minutes, into minutes. And once again, we will multiply the decimal part, the 0.8103149, by 60, because there's 60 minutes in a degree, and that will give us the number of minutes. So we know that we have 41 whole degrees, and for that part of degree, how many minutes is it? And I got 48. When I did this, I got that it was 48 whole minutes, 0.6, and it keeps on going, but I just need to the nearest 10 minutes, don't I? So 48 is closer to 50, so it would be 41 degrees, 50 minutes. Since that's an 8, we would round up, and of course that would make the 4 a 5 and put a 0 in place of the 8. So that's what we get for angle B, and let's write that. Now, I think I told you that I don't always find the other angle that way. What I usually do when I've got to find one side and two angles, when I find that first angle, like when I find that angle A is 48 degrees 10 minutes, well, don't I know that the two acute angles in a right triangle are complementary, so their sum is 90. So usually to find this other angle, I just say 90 degrees minus whatever I get for that first angle, and of course we'll rewrite the 90 as 89 degrees, 60 minutes, and we'll subtract the 48 degrees, 10 minutes, and 10 from 60 is 50, and Do you see? Now I'll leave it up to you which one's easier. Well, I think this is easier, but remember you're taking a risk, because if we got angle A incorrect, then of course angle B would also be incorrect. So I believe that we have solved this right triangle. We knew we had the right angle and we were given two sides. We found that third side and those two acute angles. I'd like to make a couple of comments. One comment is most calculators have a way to easily convert from decimal degrees to degrees and minutes. So if your calculator has a way, I would do it that way. My calculator does, and it's easier to do that than to have to multiply by the 60. But the calculators do that differently. So instead of trying to teach for each different calculator, I try to give you one way that will work for all the calculators. The other thing, let's do a geometry check on that last problem. Notice, is the longest side across from the largest angle? Well, what was the longest side? 67.8, and sure enough, it's across from angle C. Well, let's see, which of the acute angles is larger? Well, angle A. So the side across from angle A should be longer than the side across from angle B. Let's see, what is the side across from angle A? It's 50.5 centimeters, and across from angle B is 45.2. So that is the way it should be. This side should be longer than that side. Now, of course, remember that doesn't make the problem right, but sometimes if you'll do that quick little check, if you've made a calculator mistake, it will be quite obvious. That completes this lesson on solving right triangles. If you're finished with the tape, please rewind it. Thank you.